Hello everybody and welcome to 1-3 Algebraic Expressions. Today we're obviously going to be talking about algebraic expressions, so let's get going. So, very first thing, we need to make sure that we can simplify each numerical expression first. So in order for us to do that, we need to make sure that we pay attention to PEMDAS, or please excuse my dear Aunt Sally. Now, to help us out with PEMDAS, we need to make sure that we understand what each section stands for. So if I were to look at the P, I know that the P stands for parentheses, all right? But really, it also could mean bracket. It could also mean squiggly brackets. Whichever one it ends up being, it just represents the grouping symbols. All right? It represents grouping symbols. So the grouping symbols need to happen first. And I'll explain that portion when we start going in through this problem. Exponents. E stands for your exponent. So the x squared, your exponent will be the square. You have x cubed. You have that cube portion as the exponent. You can even have fractions as exponents. All right. You can even have negative numbers as exponents. Either or, the exponents will always come next. Most likely, the exponents will be outside of parentheses as well. Now, this is the part that everyone always forgets. Multiplication to division. It goes from left to right. Now, I know that some people might be thinking, well, that means multiplication comes first. And no, it doesn't. Multiplication comes first if in the equation or expression it comes first. In this equation, division comes first. Therefore, when we get to this step after the parentheses, we must divide the answer first before you multiply. So you must always make sure that when you do multiplication and division, you always start the furthest one to the left and you always work your way through to the right. The same thing goes for addition and subtraction. So your addition, subtraction, multiplication, and division will always be from left to right. Left to right. Right? No matter what. This one problem right here made headways. It actually even made the news if you didn't see that. And it was just, the problem was the answer 1 or was the answer 16? Well, I'm here to tell you that the correct answer is 16. Because following PEMDAS, we do know that we have to get rid of the parentheses first, but more importantly, we have to do what's inside the parentheses first. So we keep the 8, we have the division symbol, we have 2, and then inside the parentheses was originally 2 plus 2, but now it becomes 4. And then you follow multiplication and division from left to right. Well, from left, we start with division, so it's 8 divided by 2. Although, yes, it still has parentheses, these parentheses do not represent the grouping anymore. These parentheses represent multiplication. So 8 divided by 2 comes first, so we're going to do 8 divided by 2, which gives you 4, and then sure enough, 4 times whatever's left over, which is the 4, will give you the total of 16. Remember, parentheses come first, complete everything inside the parentheses. Then you have exponents. For this problem, we didn't have any. Multiplication and division happen from left to right. Whichever one comes first, you must do first. Adding and subtracting, once again, left to right. Whichever goes first, comes first, and you must complete first. But enough of that, let's actually get into this. So, taking a look at the very first question, we have 6 times 5 minus 2 plus 7. Well, 6 times 5 minus 2, again, we must do the parentheses first. So we have 6 times 5 minus 2, which is 3, plus 7. 6 times 3, because we're going to do multiplication next, will be 18 plus 7. 18 plus 7 gives us 25. So our answer for question 1 will be 25. Question 2. We have 7 plus 5 times the negative 3 all over the 4. Well, that's the same thing as 7. 5 times negative 3 gives you a negative 15. If you add a negative, it's the exact same thing as subtracting. So we're going to subtract the 15 from the 7, then divide it by 4. And whenever you have any sort of division problem where the line covers everything. Basically, it's saying, hey, make sure you do everything on top first, then divide by 4. So this becomes a -8 all over 4, which equals a -2. So the answer for us should be -2. And last but not least, we must do the exponents first. Notice, inside the parentheses, we have a -5. That is going to tell us if we have -5 squared, that means it's -5 times a -5, which equals 25. Because negative times a negative creates a positive. 5 times 5 is 25. Minus 4 times 4. Because 4 squared is 4 times 4. That equals 16. So what is 25 minus 16? You should get 9. Let's check our answer. Perfect. But today we're also going to be talking about how to evaluate a problem. When you evaluate something, you're taking the expression and we're giving the variables in the expression an actual value. So for the very first question, at question number 4, we can then take what we know a to be and plug it in. So our original function is a plus b over 4. Well, that's going to turn into a -2, and I'm going to make sure I put parentheses around it. Plus our b, which is 8, we're going to plug in the 8, and we're going to put it divided by 4. The next thing we have to do is we have to follow PEMDAS. We have to divide the 4 from the 8, so we'll get -2 plus 8 divided by 4, which is 2. And the answer will be 0. Because -2 plus 2 is 0. Following the same idea, we're going to plug wherever we see an x value, we're going to plug a 3 in. Wherever we see a y value, we're going to plug a -4 in. One of the things that I tend to do is I will take the original expression, the x minus x squared y, and I will turn that into its own brand new expression without any variables. So I'm going to put a parenthesis wherever I see a variable. So we have x minus x squared y. But notice I have parentheses each and every time. It's a little bit more challenging to do with multiple variables. It's much easier to do with just one, but you can still just remember where it is. So if we have an x here, we need to plug in a 3, so I'm going to put a 3 where the original x was. Right. We have another x next to the square, so again, we're going to put a 3 into where it says squared. Last but not least, we have that -4 for the y value, so I'm going to put -4. Again, the y value came after the square. Then you got to simplify it. Exponents first, so we have 3 minus 3 squared, which is 9, times a -4. I'm just going to bring down what we don't do. Then you get 3, but if I were to take a look at this, I know that this is a -9 times a -4, which becomes a positive 36, which means that our answer will be 3 plus 36, which is 39. Nice work. All right, we now must draw a line from each property in column A to the algebraic example of the property in column B. Let A, B, and C represent real numbers. So the distributive property of subtraction, we are going to draw a line all the way down here. Notice, distributive property means that we're going to be multiplying that A times whatever is on the inside of the parentheses. And the reason it's subtraction is because what happens to be in the middle of the parentheses is a subtraction expression, B minus C. Multiplication by 0 means that we're going to, well, multiply by 0, as you can see. Multiplication by -1, just like multiplication of 0, means that we're going to be multiplying by -1. The two important portions of the 0 and the -1 is following what you see. Notice, 0 times A, or 0 times any real number, will always equal 0, no matter what. -1 times any real number will always equal its opposite, negative of whatever that number is. Opposite of a sum means that we are going to multiply a sum, which is an addition solution, by its negative form. So we're going to go up here. Negative times A plus B. A plus B is a sum, and therefore if we multiply by its negative, it will become opposite. We can use that same idea as opposite of a difference, but difference is the answer to a subtraction. So that's going to come down here. Negative times A minus B. A minus B being the difference. And last but not least, we have opposite of an opposite, which basically means we're going to take the negative of a negative. So negative times negative A equals A. Simple as that. So which algebraic expression models the word phrase 2 times the sum of A and B? Well, when we think about times, we are always going to be thinking about multiplication. Seems the simplest form whenever it's almost interchangeable, really. So the word sum would represent the answer to addition. And therefore, we're talking about multiplication and addition. But can we write the expression? When you talk about sum, we're talking about the solution to addition. All right, so sum is the solution, which means that we got the answer already from adding it, which means the sum needs to happen before we multiply by 2. So how do we make sure something is done before we do anything else? Use parentheses. So we need to make sure that we have the sum of A and B come first, so we're going to put A plus B inside parentheses. And then after that, we can multiply everything times 2. So we can just do it 2 times right there. Let's check our answer. And either one of these will work. The one that I prefer the most is probably the first one that's shown that doesn't have the multiplication sign. It just looks cleaner. Write each numerical or algebraic expression by writing a letter, number, or operation sign in each box. Well, the difference of 7 and 4. The difference stands for the answer to a subtraction problem. So if we have 7 and 4 and we're trying to find the difference, it will become 7 minus 4. The product, which is the answer to a multiplication, and sometimes you might see it as a little dot, of 3 and x, will then become 3 times x. The number y increased by 2, increased by stands for addition, so we now will use y plus 2. The quotient of 48 and 3, the quotient is the answer to a division problem. So the quotient to 48 and 3 becomes 48 divided by 3. The number t is doubled, then decreased by 1. We have to pay attention to which is happening first. In this case, the number t is being doubled before it is decreased by, but doubled represents multiplying by 2, and decreased by represents subtraction. So if I were to rewrite this, it would become 2t minus 1. And 5 taken away from q. 5 taken away from q is subtraction, which is what they give you, but we need to remember that q will always come first in this one because q is our original amount. 5 is what we're pulling from our original amount, so it's q minus 5. You had $150, but you are spending $2 each day. Write an algebraic expression that models this situation. We need to figure out one thing, and that is, what does the variable stand for? So we're going to let d equal something. And normally we let the variables kind of look like what it's supposed to stand for. So for me, I'm going to let d equal the number of days. D for days. Complete the model to write the algebraic expression. Relate. What is our starting amount? You had $150. So our starting amount was $150. The amount spent per day was $2. So I'm going to put a 2. But each day, that per day part, becomes the number of days, which is what we said our variable d stands for. So the number of days becomes d. So how can you write that as an expression? You just have to simplify it now. 150 can't combine into anything else because there's no other like terms. But that 2 times d can look a little bit nicer, and we can change that to a 2d. So we have the 150 minus 2d. What is the value of the expression 2 times x squared minus y squared all over 3? For x equals 6 and y equals negative 3. Substitute the given values. Where I see a x, I'm now going to put in a 6. So what I'm going to see is a 6 going to where the original x spot was. The new y spot is not going to be a y anymore, it's going to be a what? That's right, -3. Now the one thing I will say is make sure when you put the -3 in, that especially since we're squaring something, put parentheses around it. And you really should put parentheses around the x as well. And I can kind of show you down here in the reasoning. So in order for us to simplify it, we just have to break it down. So I'm going to rewrite it really quick. So we have 2 times 6 squared minus that 3 squared, or minus the -3 squared. And all of that is going to be over 3. Well, complete what's inside the parentheses first, which means we have to do the exponents first. So this will become 2 times 36 minus -3 squared becomes a +9. So it's minus a +9. And it's still inside the parentheses, and it's going to be all over 3. Now that is where the parentheses are needed, because if I were to do -3 squared, that would actually give me a negative times 3 times 3, which gives you a -9. Right? However, in parentheses, it forces you to make sure that you do -3 times the -3. It forces you into having a negative for both spots, and therefore creates a +9, which again, followed by that negative in the middle, make sure that we're subtracting. Well, now we still need to make sure that we simplify everything inside the parentheses. So we have to do 2 times 36 minus 9, which is 27. And then we're going to divide all of that by 3. We can do one of two things here. Since it's multiplying and dividing, we could just keep following PEMDAS, multiply on top. 2 times 27 will give us 54, and we're going to follow through with that idea. So we got 54 divided by 3. And 54 divided by 3 equals 18. And this right here is the value of this expression when x equals 6 and y equals -3. Now, in basketball, teams can score by making 2-point shots, 3-point shots, and 1-point free throws. What algebraic expression models the total number of points that a basketball team scores in a game if a team makes 10 2-point shots, 5 3-point shots, and 7 free throws? How many points does it score in all? We have to define the variables. The very first one that we have is let t equal the number of 2-point shots, which means that we're going to let h equal the number of 3-point shots, and let f equal the number of free throws. Right. Complete the expression. Well, we have to pay attention to how many points they count, right? So if we have 10 2-point shots, well, we know that 2 points is a shot, so 2 points represents t, which is going to be the number of 2-point shots, so it's going to be 2t. 3 is the number of points that we get from a 3-point shot, so we have to do the number of 3-point shots and attach that to the 3, because that's how many points you get per 3-point shot. And last but not least, you only get 1 point per every free throw, and therefore we're just going to have an f. Now let's evaluate the expression for t equals 10, h equals 5, and f equals 7. Well, using the information that we were just given, I'm going to plug everything in. We have a 2 times t, but our t is 10, so we're going to put 10. Plus a 3 times our h, which we are given 5, so I'll put a 5. And f was 7, so I'm going to add our f, which is going to be 7. Again, using parentheses wherever I see a variable, just to make sure it guarantees the correct answer each and every time. 2 times 10 is 20. 3 times 5 is 15, and then we have that 7 by itself, adding in between each and every one. So 20 plus 15 will give you 35, plus 7 equals 42. So the answer will be the team scored 42 points. The expression 5ax plus 6y minus 7 has 3 terms. You have the 5ax, the 6y, and the -7. Notice the terms are being separated by an addition or subtraction sign. The coefficient is the numerical factor of a term. In this case, it's 5 and 6. Notice, this is a fancy way of just saying, hey, it's the number that's being multiplied by the variable. So we have the 5 that's being multiplied by a variable, and the 6 that's being multiplied by a variable. It doesn't matter what the variable is, if it's the a, the x, or the y, as long as it's being multiplied by a variable, that number will be a coefficient. And then you have the constant term, which is the term with no variables. In other words, the constant term is the term that is by itself completely. It's -7. But notice, in the problem, we would not read that as a -7. You would say that that's 5ax plus 6y minus 7. But the constant always accepts the sign. And so does the coefficient. The coefficient will always accept the sign. In this case, the 5 is positive and the 6 is positive. So we have a +5 and a +6. But if we look down here at question 25, you'll notice the very first coefficient is going to be the number in front of the x squared, which is 2. However, the number in front of the x is a 3, but attached to that 3 is a minus sign. So this is actually going to be a -3. Jumping over to question 26 to finish off the coefficients, you have the very first one, which is going to be the very first thing attached to the variables, which is that -4. That one's straightforward, it's right on the outside. We also have a +8, which means the other coefficient, or the other number that's attached to a variable, is going to be a +8. But let's talk about the constants, the numbers by themselves. The number that's by itself in the beginning, 25, is going to be 5. That's its constant. The constant for 26, so the number that's by itself for 26, will be a -3, or also known as a -3. Good work. So, combine like terms. What is the simpler form of the expression -4j squared minus 7k plus 5j plus j squared? At the right is one student's solution. But where did she mess up? Well, when you combine like terms, the like terms come when the variables are identical. So if you look right here, a -4j squared has the same exact variable as j squared. But notice, -4j squared and j squared do not share the same variable as j. J squared is its own special number. J is completely different. We cannot combine those. They're not like terms. However, we must combine these because they are like terms. So if we were to combine them, you would get a -3j squared minus 7k plus 5j. So what error did she make? As you can see, we got what she did right there. Problem is, she took it a step further. She did -7k plus 5j, which you can't combine. They're not like terms. Therefore, the error that she made was that she combined -7k and 5j together. And what this says is the terms -7k and 5j have different variables, so they can't be combined. And simplify the expression, like we did up here, and like what Rose did over here. The simplified expression can be written out by moving the j squared closer to the -4j squared if you would like, just to make it so it looks a little bit easier to solve, and then combining these like terms to give you a 3j squared, but this is actually wrong for them. It needs to be a -3j squared because -4 plus 1j squared will end up making it farther negative. Alright guys, we finally made it. We're into the lesson check. So, let's end this one nice and strong. How are algebraic expressions and numerical expressions alike? How are they different? Can you include examples to justify your reasoning? Well, how is an algebraic expression different from a numerical expression? An algebraic expression contains one or more variables, while a numerical expression contains only numbers. That's it. I mean, that is the only difference. What are the similarities between the two? They're both expressions. They're both made up of mathematical operations. They both contain numbers a lot of the times. One just always contains numbers, and the other one has some variables every now and then. And like we've done before, you have to put an n next to the numerical expression and an a next to the algebraic. In other words, is there a variable or is there no variable? So, the very first one, we have 3x plus 2. There is in fact a variable right here, so therefore we are going to say that this is algebraic. 6 times 4, there is no variable, therefore it's numerical. We have an a minus 7, which means that this is going to be algebraic. 4 times 1 plus 10, no variable, numerical. Actually, for the next one, 5g divided by 3 plus h, we have 2 variables for there, so that is absolutely algebraic. Have a wonderful day, stay out of trouble, don't do anything stupid, and I'll see you later.